let's get started. So it's more or less the beginning of the year, and I did want to just set aside a lecture. We kind of finished the previous lecture series last week, and we will be beginning a new lecture series next week. But I wanted to take a moment to look back at 2021 from the perspective of climate change. And as I've said to you on several occasions, I think this is the single most urgent issue the world faces today. And so it's appropriate to take stock on a regular basis, even if we're not dwelling on it in a sustained way. We can at least update ourselves on what's happening in the world. And so I'm going to start by highlighting some of the major developments of 2021. And to begin with, the idea that the weather that we saw in 2021 was truly extraordinary, I think is anecdotal, right? Whether it's the smoke in Northern California from the wildfires or the smoke in New York City from the West Coast wildfires that made its way all the way across the continent, whether it's ice storms in Texas or tornadoes in Kentucky in December, or the extraordinary heat wave that gripped the Northwest, the Pacific Northwest in June, right? There was an awful lot of extreme weather in the news. But once we look at the planetary data, it becomes all the more obvious that the anecdotes reflect an underlying step function change, not just a progress, but a dramatic increase in extreme weather. And the temperatures tell the tale. And the idea that I would highlight here is that in 2021, temperature records were broken. And please note, this can be 5 degrees up or 5 degrees down from the previous record, because what climate change is doing is putting more energy into the atmosphere and disrupting the processes that stabilize the climate. Most importantly, the Gulf Stream and the jet stream, the major currents of water in the oceans and air in the stratosphere. And the result is that the processes that stabilize the climate in the more ordinary sense of that term, the temperature out your door when you wake up in the morning, appear to be increasingly unstable, not operating the way in which we expect them to. And so the fact that those records were broken by 5 degrees or more in 2021 more often than they had been broken in the 85 years prior to that combined, right, is a pretty clear indication that what had been predicted by climate scientists is in fact occurring. And 2021 is really the first year in which we are seeing this trend consolidate and a kind of new normal to our weather emerge. And the evidence then adds up to the idea that we may have already destabilized the Earth's atmosphere more than the existing models predicted we were going to do at this point in the process of climate change. And so that the existing models failed to capture some of the interaction between, for instance, the jet stream and the Gulf Stream, right? Very complicated processes to capture. And so all of that to say, and I'll say a little bit more about this in a few minutes, but one of the things that I learned in doing some further research on this, and the way in which we have learned this is by drilling into the Earth's ice cores. And these are in the Antarctic or the Arctic or in Greenland. And it turns out that the ice in those regions is literally more than 1 million years old. And so when you drill into the ice, layer by layer by layer by layer, scientists can analyze the thickness of the ice and determine the temperature and the degree of precipitation, as well as the chemical composition of the frozen water to figure out what was going on 10,000 years ago, 100,000 years ago, 500,000 years ago. It's as if all of a sudden we have a million years worth of weather reports consolidated into a long column of ice, right? And so one of the things that scientists discovered, and let me see, somewhere I wrote down the name of this. Let me see if I can find it. Yes, sorry. These are called Dansguard Osher cycles, and that's after the two scientists who discovered it. They're, I believe, Danish scientists who were working in Greenland in the 1950s and 1960s. These are cycles of rapid change in the temperature of the Earth's surface, and so one of the things they discovered when they went back 50,000, 100,000, 200,000 years is that the temperature often changed by between 18 and 27 degrees Celsius. And so if you do the math, that's more than 30 degrees Fahrenheit in a 15-year period. And that those cycles occurred on a relatively regular basis, like maybe every 1,000 years. And if you think about this for a moment, where I am, New York City, right? If the temperature were to increase over 30 degrees in the next 16 years, in the summertime, New York City would be hotter than Death Valley is right now. And I'll ask you rhetorically, how many people live in Death Valley, right? And the answer to that is really no one, other than the park rangers who we pay and station there temporarily. And that's because the human body doesn't do well at that temperature. We tend to shut down and even die if we're exposed in a sustained way to temperatures much over 110 degrees Fahrenheit. And unfortunately, right, the population of the New York City metropolitan area is a little bit larger than the population of Death Valley, by the tune of maybe 20 million more people. And so if over the next 15 years, the temperature in New York City increases by 30 degrees, it may be that we're going to have to relocate 20 million people. Now, I'm not saying that that's going to happen that quickly, but what I am pointing out, and this is, I think, the very interesting intersection between climate science and anthropology, the speculation right now is that when we look at when human civilization, as we like to think of it, began, right, which is to say larger scale communities with, agriculture and states and more stable social order began. They began in Persia and China and Egypt and elsewhere around the same time. And that's around the time that we stopped having these radical shifts in our climate. And the issue here is quite straightforward. If you build a big city, it's really hard to move if the sea level rises by 10 or 20 feet, or if the temperatures rise in such a way that agriculture is no longer possible, or human beings can no longer inhabit that region. And so there are strong advantages to a nomadic way of life in a world in which the atmosphere, the climate changes rapidly, unpredictably, and in severe ways. And there does seem to be some evidence that we may be pushing the world back in that direction, coming out of what we're seeing in the weather of 2021. We have to be careful here. Part of the reason that we're worried that the models were too optimistic is because the models build in so many complex interacting factors that it's very hard to rely on them. And to be clear, when we're dealing with the intersection of economic models and models to do with the environment that include the ocean and the atmosphere and forests and cloud behavior, we're dealing with an enormous range of complexity. And so as opposed to trying to get the model right, the new state-of-the-art research method is to run these models maybe 10,000 times with slight variations in the parameters and then take the average, right? And so we don't know for sure that 2021 means that our models were too optimistic, but it certainly looks like things may be moving quicker and in the direction of instability much more quickly than we had realized. I've spoken with you recently about the UN-sponsored conference on climate change in Glasgow. I'm not going to rehearse what we've already said. I think Bill McKibben captured it nicely when he said big conference, modest results, right? And the idea here is, you know, we got almost every country in the world together. It lasted for a couple weeks, serious negotiations ongoing, but the result is really just more kind of commitments without enforcement that don't seem adequate to the scale of the problem. And so you could ask why. And the simple answer is that the world is addicted to cheap energy and that carbon is still the cheapest source of energy in the world. And I think to make it a little bit more complicated, a little bit more adequate, you could say, look, the problem, climate change, is moving so quickly and has such enormous costs associated with addressing it that it's very difficult to solve. Whereas what we're seeing around us is not generating the sense of panic that would be necessary to produce the resolve to undertake the enormously costly measures that adequate policy involves. And so it does seem to me that what Glasgow reveals, and in a sense it's perfectly predictable, is that the countries of the world are still not ready to undertake the heavy lift to decarbonize our economy, to change our energy infrastructure in a way that will make almost everything we take for granted much more expensive or simply unavailable. And there's a further dimension to this, and I'll focus on the United States where we all are. And that is that, you know, we have about 4% of the world's population in this country, and we have produced about 30% of the aggregate carbon dioxide in the atmosphere, right? And so there's also a distributional problem here. Right now, in ways I'll show you in a moment, China is the world's largest emitter of carbon dioxide. Is it fair to ask the Chinese to reduce dramatically their carbon emissions? And in a sense, the obvious answer is no, right? Why should the US get all the benefits of industrialization, of having emitted a third of the greenhouse gases, and China have to pay the costs of the fact that we used up all of the excess capacity for carbon in the atmosphere before they really started to industrialize, right? So the additional factor here is, how do we fairly or equitably distribute the costs? And one thing that seems clear is that the United States and the other rich countries of the world, I think Europe has 7% of the world's population and contributed 23% of the carbon that's in the atmosphere right now. For the world to really make progress on this, the United States, Europe, the countries that have already industrialized and are the richest per capita, are going to have to subsidize the rest of the world doing a kind of clean, green industrialization process. Now, the one piece of good news in all of this is that over the year that just passed, the price of renewable energy fell and fell more rapidly than it has in any year previous to that. The result is that the production of energy from renewable sources like wind, which is really showing some great promise right now, like solar, geothermal, and now we have to add nuclear probably to the list, that the energy that is being produced via those sources that do not emit carbon dioxide or other greenhouse gases into the atmosphere has increased substantially, as quickly as it ever has over the last year. We're up to the point where almost 10% of the energy of the United States comes from renewable sources. And that's a place many people didn't think we would get to for another decade. So there is some good news in all of this. Let me immediately offset it by noticing that two things occurred in 2020 that we really can only see well at the end of 2021. One of them is that in April of 2020, global carbon emissions fell by 16%. And of course, that's because of the pandemic and what the pandemic did to air travel, to industrial production. And so the world economy hitting the brakes is the best thing that we can do for carbon and other greenhouse emissions right now, because we don't have enough renewable energy sources to replace them. Here's the caveat, which is that in May of 2020, we saw a new record for carbon parts per million in the atmosphere. I think it was 417 parts per million carbon dioxide in the atmosphere. And how did we set the record for carbon dioxide in the atmosphere? The month after there was a major contraction. The metaphor here that Elizabeth Colbert uses, and I think it's a good metaphor, is when we reduce carbon emissions or other greenhouse emissions, it's like turning down the tap on your bathtub. As long as the stopper is still in the bathtub, that means the bathtub fills less quickly, not that it stops filling or reverses. And that's the situation we are in the world right now. We have already treated our atmosphere like a garbage disposal for our carbon. And there is so much of it in the atmosphere, even if we slow down dramatically, it still increases. And by the way, the carbon dioxide stays in the atmosphere for thousands of years, and it continues to trap heat, which continues to contribute to self-reinforcing cycles over that period. And so we need to accelerate this, and we need to also recognize that even if we somehow miraculously had a huge breakthrough with hydrogen or fusion or some other energy source, it wouldn't solve our problem overnight. And then the final aspect of this, in ways that I've spoken with you about recently, the major climate initiative in this country, in the United States, collapsed last month at the end of 2021 when Joe Manchin withdrew his support for Build Back Better. And I'll speak a little bit more about that in just a moment. I'll just give you the overview. Again, this is just reprising stuff that we looked at during the Glasgow conference. What you can see, and I'm sorry there's not a scale on this, but what you can see is up here, right? We were on our way to maybe 6 to 9 degrees Celsius global climate change before the Paris Climate Accords of 5-6 years ago, right? And so we were, in other words, headed to certain global catastrophe, an uninhabitable planet, a planet that maybe enters a spiraling cycle of superheating and becomes uninhabitable for all life, not just for humanity. But in carbon, terms at least, but in terms of other greenhouse emissions as well, Paris helped. And so we have reduced our carbon emissions and other greenhouse gases and are now headed towards maybe only 3 degrees, which again is a global catastrophe, is a level of temperature rise that makes large portions of the currently inhabited Earth uninhabitable and maybe still unleashes self-reinforcing cycles that will be impossible to arrest and result in out of control climate change. And so one of the things to notice, of course, is that the current policies do not meet the pledges from Paris. And Paris used the figure of 2 degrees or substantially below 2 degrees. And the pledges, which are non-enforceable, it's an accord, not a treaty, mainly because, right, President Obama at the time knew that if he negotiated a treaty, the Senate would not ratify it. And I'll say more about this in a moment, but please note that basically the Republican Party in the United States, which has been in control of the White House for a dozen years in the 20th century and has also been in control of the Senate for the majority of the 21st century. Did I say 20th a moment ago? 21st century. That basically they have never supported any climate change legislation or treaty. The presidents have not passed it. As a matter of fact, Donald Trump rolled back a whole bunch of stuff. George W. Bush did as well. And so Barack Obama was probably correct in calculating that there was no way that he could negotiate a treaty in Paris. Instead, he negotiated an accord. The difference is that it has no enforcement mechanism. These are pledges. We give our word, we shake your hand, we look you in the eye, and then we go back home and do what we need to do to get reelected. And very often that's going to be different from what we pledged to do in Paris or Glasgow. And that's part of the reason that so many people are so disappointed in what came out of Glasgow. But having said that, our policies are clearly not in accord with our pledges. Our pledges are not in accord with where we need to be, right? And to be as clear as possible about this, when the Intergovernmental Panel on Climate Change issued its new report in the build-up to Glasgow in the middle of 2021, summer of 2021, it said, look, if we were to get to 1.5 degrees, and by the way, to probably get to 1.5 degrees, we've got to get to zero emissions globally in the next decade. And I say that slowly to emphasize that that's nearly impossible to imagine. Maybe, though it's quite improbable, the United States gets there. Maybe Europe gets there. But the idea that China, India, Brazil, some of the most populous but still less well-developed countries in the world, also get to zero emissions, it defies common sense to think that would be the case. But if somehow miraculously we were to get to zero emissions in a decade, we would get to 1.5 degrees at the end of the century. And the Intergovernmental Panel says that there's a 50-50% chance that that would still be a global catastrophe. And so to get to a coin toss chance of it not being a global catastrophe, we have to have nearly miraculous efforts. We're certainly nowhere near. And very quickly, again, just to review, China is now the world's largest emitter, though historically it has not emitted nearly as much. I think it's emitted maybe 7% of the aggregate carbon dioxide in the Earth's atmosphere, and clearly has a much higher percentage of the world's population. But in 2020, 2021, it is the largest emitter. It's emitting 14 gigatons of carbon. And as you could see, it would have to cut its emissions in half, basically, not quite half, get it down to 8 gigatons to be compatible with that 1.5 degree goal. And by the way, it's building several coal-fired power plants per year. And by the way, the other really big piece of news about 2021 is that carbon emissions went up significantly, 6% in 2021 alone, because the price of natural gas went up high, quite dramatically in 2021. I don't have the precise figure in front of me. And when natural gas becomes more expensive than coal, countries switch back over to coal-fired plants. And so unfortunately, this happened in Europe, this happened in the United States. This seems to be reviving the coal industry in 2021 and accounting for how far off China is from where it would need to be. The United States is far off as well. We're emitting 6 gigatons per year and need to be closer to 2 or 3 gigatons. European Union doing a little bit better, India doing a little bit better. But basically, the world is not anywhere close to where it needs to be. The United States had a plan under Joe Biden and the Democrats to do something about this. That plan is contained in the portion of Build Back Better that had to do with climate change. That's roughly $400 billion of the overall maybe $1.3 trillion that bill wanted to spend. And the 3 major provisions of the bill in terms of expenditure and effect: first, creating a large pot, maybe $200 billion of money to subsidize wind, solar, and nuclear power to make them less expensive so that we could continue the transition to renewables in our economy. The second big proposal was to give substantial rebates to people who choose to buy electric vehicles, maybe higher than $10,000 per vehicle if you buy an electric vehicle made by union workers. And then finally, and I want to emphasize this because I think this is extremely important, and this is one of the places I'm going to go today, which is that the bill also contained a substantial pot of money to subsidize research into technology called carbon capture technology. And one way to think about this, right, and I want to be as clear as possible, right, the assumptions on this diagram, right, so this diagram assumes that we would get to the 2030 goal that the US has committed to by around 2035, if all of this had been passed in 2021, right? And that the 2 provisions that are doing most of the work are the first and second provision. That the third provision is much more a long-term idea. We need carbon capture technology. And so what does that mean? Well, one way to look at what has been happening to the world over the last at least 200 years, right? Since James Watt invented the steam engine and we started taking coal out of the ground and burning it to produce energy, is that we have been taking carbon that was stored in the earth millions of years ago out of the earth and putting it into the atmosphere. And that ultimately, given how unrealistic it is that we are going to immediately stop doing that, right? Which is, even if we did it at the end of the decade, totally improbable to the point of probably being a fantasy, we still would have that bathtub most of the way full, maybe so full that it's going to get us up to 1.5 degrees or more. So we've got to start figuring out, can we take the carbon out of the atmosphere and put it back into the earth? And this would be, if you will, a second step, not the one that we do in the next 10 years, but given that we're not going to get there as a planet, we're going to overshoot the amount of carbon we put into the atmosphere. At some point, we're going to have to figure out how to take it back out, or we're going to have to shop for another planet to inhabit. right? And I want to be as clear as possible. There's a term here which is called solution bias. It's a perhaps one of our deep-seated cognitive biases. Maybe it's not. Maybe it's a product of the Enlightenment. But the basic idea is, I've got a problem. There must be a solution, right? And so if I just think hard enough about it, if I just do the research, if I just use my imagination, if I just subsidize the scientists who are so good at this, eventually we'll find the solution. And that would be nice, right? That would be good. But it doesn't follow from the fact that we face an enormous and potentially catastrophic, fatal problem, that there is a solution, right? And so we have to be careful in thinking that we can be certain that this research will succeed. But at the same time, given where we are, we've got no good alternative other than investing in the carbon capture technology. I'll say a little bit more about that when we get a little further into the lecture, but that's what we didn't do when we didn't pass Build Back Better. Now, please note that Build Back Better may be resurrected, and Joe Biden and Joe Manchin are both talking about starting over. And it may even be that a standalone climate change bill will pass the Senate. Let us, hope and pray that that will be the case. But it's not going to happen easily. It's not going to happen readily. It's one of the things I hope you might take away from this lecture, is that we need to be encouraging everybody we can to bring pressure to bear for the Senate to split off the climate change part of Build Back Better and to try to get it passed. Because as urgent as the other stuff is, this is an existential threat to not just our species, but all species. The entire eco or Gaia system of the planet is in danger if we can't bring carbon emissions under control and start reversing, start taking them out of the atmosphere. The evidence here, right, of how bad the last year was in terms of temperatures. Right, the diagram at the bottom shows you the larger the circle, the higher the record is that's being broken. And you can see, right, the New Mexico-Colorado border, it seems like it got maybe 12 or 15 degrees hotter than it's ever been before. And there's one town in Canada, in particular in British Columbia, pretty close to the Pacific Ocean, that got its temperature record broken on successive days, I think by 10 degrees, 18 degrees, and 20 degrees. It went from 111 to 118 to 123. I'm not positive I've got the numbers right. And on the fourth day, it burned to the ground, right? And so this is a community that had never been hotter than 100 degrees before. This is what is happening. And you can see thousands of people died in the Pacific Northwest from heat exposure. Hundreds of people died in Texas from ice storms. And when we look at this in a less graphic, more statistical way, one of the things that meteorological historians, learning that there is such a field, say is that in a sense, this was a statistically impossible year. So starting with this diagram, which looks at the global trends and compares mid 20th century temperature going back with late 19th century into the last year, you can see for the most of the period before the middle of the 20th century, the temperatures were on average cooler. And then beginning in the middle of the 20th century, the temperatures get warmer. And then beginning in the late 20th century, they go up and up and up and up. And then when we look at the margin by which temperatures were broken, right? 11 degrees, 10 degrees, 9 degrees. And what the meteorological historians are saying is, look, you should break a temperature record by 1, 2, 3, 4 degrees in a year. And then maybe 5 years later, you break it by another 1, 2, 3 degrees. You don't break these records by 10 degrees per year. And so this is a totally exceptional year, and it is the year in which it appears that really we may have broken out of what's sometimes called the civilizational band, the period of more moderate temperatures that has lasted about 10,000 years and that coincides with human civilization may be coming to an end as a result of human induced anthropogenic changes to the Earth's atmosphere, to the Earth's oceans, and what they're doing to then the interconnected systems that regulate the planet's temperature. One of the books I was reading talks about a geologist at Brown who uses the metaphor of putting carbon into the Earth's atmosphere being like adjusting the thermostat on the Earth's temperature. We have been turning the thermostat up and up and up for 200 years at least. And now we're really beginning to see it may take a little while for the planet to heat up, but it is happening. So how do we explain what's been happening? One of the big developments is the rapid melting of the Arctic Ocean. And this is happening in the Antarctic as well. And some of you may be seeing the news that the Thwaite Glacier, the so-called Doomsday Glacier, the glacier that one of the metaphors that's used is acts like a cork, keeping the ice flow of the Antarctic from reaching the ocean, that it's beginning to degrade more rapidly. And if its degradation becomes irreversible, then it could be that it will trigger a chain collapse of much of the Antarctic ice cover. And so that's the Antarctic. This is already happening in the Arctic. And one of the things that we're seeing is that the ice melt in the North Pole and Greenland is occurring much more quickly than people anticipated it would occur. They're discovering large caverns that where the glaciers seem to have melted from within, melting from the bottom, water that instead of going over the surface of the glaciers creates a fissure and then goes into the middle of the glacier. And water is very good at conducting heat. It then accelerates the decay of the glacier, the calving of the glacier as it falls into the oceans. And so the Arctic Ocean's change is much more rapid than many of the models predicted it would be. It is creating sea level rises, but it's also creating a greater amount of fresh water because the ice in the water it contains is fresh water. And that's affecting the salination, the degree of salt concentration in the Arctic Ocean. It's getting into the Gulf Stream more quickly than we had anticipated. And it's affecting both the jet stream and the Gulf Stream more rapidly than people had anticipated. It appears that the Gulf Stream, right, that the major currents in the ocean, which move water at 100 times the rate of the Amazon, right? So giant flows of water that move warm water from the equator north and cold water from the poles south, and so moderate the temperature of the world and are responsible for the climatic weather and temperature patterns for most of the northern hemisphere, that those massive streams of water are slowing and slowing not marginally, but quite significantly. Similarly, the jet stream, right, which is now the atmospheric as opposed to the oceanic process, right, the circulation of air throughout the planet, which is basically, and I'm out of my depths here, I will readily admit, but my understanding is the basic force driving the jet stream is the temperature difference between the poles and the equatorial regions. And so as the poles have warmed, the differential has diminished, the jet stream has weakened and become less stable. That's part of what then led to this high pressure zone settling and staying over the Pacific Northwest. It's part of what led to an Arctic dome being able to escape the Arctic region and get all the way to the southern United States and create those ice storms in February of last year. And so this is right, the changes that models predict. And we're now seeing them occur, but occur more rapidly and severely than most of the models had predicted. And it could be, right, we're working here with the limits of our knowledge, the limits of our computational capacity. It could be that it'll turn out that 2021 was anomalous, but I certainly don't think we can rely on that. The other possibility is that our models of climate change were just too optimistic, did not understand all of the processes at work in particular ecosystems or their interconnection, and that we're now getting climate change in a more accelerated and severe form earlier than those models anticipated. So what happens if it turns out that climate change is occurring in a more accelerated basis than we realized, which is the world changes much more rapidly. We have a new normal in which we can anticipate multiple intersecting crises occurring at the same time, right? And so the fires that occurred in the Northwest and in California and in Colorado all at the same time would be an illustration of this. And one of the things that happens if we don't, and this is another thing Build Back Better and the infrastructure bill are designed to do, if we don't invest rapidly in increasing the capacity of government to cope, we are going to be overwhelmed by the intersection of multiple extreme weather or temperature related crises. And I'll get to this in a moment, but I do think in addition to talking about the capacity of government to cope, we have to talk about the capacity of civilization to cope. And it's one thing for a government to be overwhelmed, it's another thing for a civilization to be overwhelmed, and for ecological decay to begin to produce civilizational decay. And again, not a happy conversation, but it is the conversation that young people are starting to have. Is it ethical for me to bring a child into the world when I cannot be certain that if she has a natural human lifespan, that the ecology of the planet won't be altered so radically by the time she is mature or old that civilization might be in danger, right? In addition to those worries, we do have to worry also that self-reinforcing cycles are beginning to take hold. The most obvious of these is the collapsing of the ice caps, right? Because the ice caps don't just store all that ice and then regulate the Gulf streams, they also reflect an awful lot of sunlight back out into the atmosphere and ultimately the solar system, right? Regulating the temperature of the planet. And if they collapse, if they are replaced by brown earth or green forests and grass or greenish bluish water, those are all surfaces that absorb more of the sun's heat and radiation, its energy, and so accelerate the process of climate change. And we get into a scenario in which climate change causes events that cause more climate change. I'll talk more with you about that in a few minutes, but that is, I think, what we're seeing. And so we're more and more impressed with the idea that we are unleashing processes that we really can't control. And so we have to take steps now, both to slow the process of climate change and to mitigate its effects. Um, I'll just very quickly point out to you the obvious. The planet is getting hotter. This is the civilizational band. This is where we are now, right? And so we're back to, in a sense, one of these periods that was regular 10,000 or 100,000 years ago, but that we haven't seen for the last 10,000 years, where we leave the band of temperatures that have made our climate stable. Again, review, but just to be clear, right? You know, when we look at what the ice core contains, we can see radical changes in the level of carbon in the atmosphere going back 800,000 years. And we can also see that the temperature changes in concert with the change in carbon dioxide. This is a causal relationship. Carbon dioxide goes up, temperature goes up. Carbon dioxide goes down, temperature goes down. Here's the distressing thing. Carbon dioxide is now higher. And by the way, that record we passed in May of 2020 was 417 parts per million, right? And so this diagram is a few years old, and it's got the record at 380. So we're even further off the chart in terms of this diagram. And as you can see, right, that the carbon dioxide concentrations have been going up really only very recently. And there's a debate among climate scientists over the long versus the short Anthropocene. Is this really only 200 years, or maybe for 2,000 years? And through agriculture have human beings been doing this? But it's really very recently that we've been seeing this kind of process unleashed. I won't go into this in detail because of our time limits, but you are familiar, I believe, with the basic idea here. One way to put this is that for the last 200 years, at least, humanity has been rolling up the windows in the car we've got parked in the parking lot, right? We have been putting gases into the atmosphere, carbon dioxide, methane, etc., that prevent the sun's energy from escaping our atmosphere, force our atmosphere to retain more of that energy, and that is heating the surface of the planet. I want to conclude, and I'm seeing I've only got a few minutes left, by talking with you about two new areas, new for me, you know, and I think that we're beginning to understand better and better. One of them is the oceans. And so I'm going to just present this in a few different ways. Again, very similar to the diagram you saw for global temperatures. And please note, the oceans are at many places a mile deep, right? They're vast. They cover 70% of the Earth's surface. We don't fully understand what's going on in the oceans, right? We don't live there. We haven't explored them. And so it's increasingly, we're getting better at measuring the temperatures, but this data really only goes back to 1960 and may not be fully accurate, may underestimate, may overestimate the problem, because we don't get to sample the whole ocean. We just take small samples. But as you can see, based on those samples, the temperature in the oceans have increased dramatically. You can see when you look at it in terms of a map of the world, right? Places where the surface temperature of the ocean has increased by 6 degrees or more, places where it's increased by more like 4 or 5 degrees. And this is an area of particular concern. If I've got my map right, looking at the Bering Straits, given its extreme importance to the Gulf Stream. And then when we break it down, and this is where things get complicated by surface, right? What we can see is that the majority of the heating occurred at the surface, you know, when I say surface, 2,000 feet or less but that there is also heating occurring um, in the deeper depths of the oceans. And so just to say for a moment why I'm concentrating on this, it appears, again, that our models did not fully take into account, and I'm saying "are" as if I'm a climate scientist, I'm not, the models did not fully take into account the degree to which the ocean would absorb the increased heat present in the atmosphere of the planet, store it, and then slowly release it, right? And so water is a very efficient conductor of heat. It covers 70% of the Earth's surface. The surface of the water heated up quickly, but then a fair bit of that heat was transferred into the deeper portions of the oceans. It's not going to stay there forever. The ocean is going to keep radiating that heat back out and slowly increase the temperature of the planet. Some models believe even if somehow we stopped all emissions today, not 10 years from now, today, we would still exceed 2 degrees by the end of the century, Celsius climate change, because the oceans would just keep heating the planet. The I won't go into detail on this, but this is something we've looked at together before. The way in which, right, this vast conveyor belt, planetary conveyor belt, that takes cold water from the polar region and pumps it south to the equatorial regions, warm waters from the equator and pumps it north, the way in which this moderates the temperatures throughout the planet, and the way in which this could be threatened by both the heating of the Earth and the decreased salinity of the Arctic Ocean is, I think, very worrisome. And again, this is just a more graphic representation of the water that comes from the equator deep into the ocean and then rises as it gets closer to, in this case, the Antarctic. And one of the things that I learned in preparing today's lecture is that this sometimes takes 100 years. And again, so it's very difficult to map, to understand. These are those glaciers breaking up and the increased fresh water being let into these oceans that threaten those cycles. The other thing that I wanted to focus on just for a moment as kind of a new topic in thinking about climate change, at least new to me and so new to what I'm sharing with you, has to do with the melting of permafrost. And you may have seen there's a long article on this in last week's New Yorker. And one of the things that one of the climate scientists refers to this as is the wild card of climate science, in the sense that it wasn't really built into most of the models. It wasn't well understood. But what we're beginning to understand is both the vast size of the Earth's permafrost, that it covers a territory as large as North America, mainly in Russia, but also in North America, and Russia in both European and Asian Russia, and that in places it's a mile deep, and that it does appear, much like the ice caps, that some of that permafrost has not thawed for 600,000 to 1,000,000 years. It's part of the reason that, for instance, in Siberia, every now and then they unearth a whole well-preserved woolly mammoth, is because it hasn't been disturbed, and it contains a great deal of organic matter. And if that organic matter were to begin to melt and decay or get eaten by microbes, it would release in total 1.5 trillion tons of carbon, people estimate, which is twice the current carbon in the atmosphere. So right now, we've emitted about a third of the total carbon in the atmosphere. So 2/3 of it is there due to natural processes. 1/3 of it is there because we've burned so much coal and oil. But if the permafrost were to melt and microbes were to digest all that organic matter, lots of carbon, lots of methane would be released into the atmosphere. And this is another one of these feedback loops that might be irreversible once it gets started. And so to be clear, as I learned, there are different kinds of permafrost. One kind of permafrost is called Yadoma. I guess that is a Russian word. And that's the kind of permafrost that has a large amount of water in it. A lot of the permafrost is only 20% water and mainly sand and silt. And it actually has less biological matter in it. The kind of permafrost that has a higher concentration of water has more biological matter in it, but it also has this additional feature, which is when it melts, it pools. And what that means is it creates marshes and swamps, eventually ponds and lakes. And this unleashes a self-reinforcing process because you get surface water. The surface water absorbs solar energy. Water conducts heat. And so the ponds start to enlarge and go deeper, and they become lakes. And the lakes then continue to grow as more and more permafrost cascades out of the permafrost into the lake. The walls collapse, and then you've got a self-reinforcing cycle, and this could release tremendous quantities of methane and carbon dioxide. One of the things that's distressing about this, the permafrost, even if it melts, tends to refreeze in areas where it's not Yadoma, where lakes and ponds don't form. One of the reasons there's life on Earth, one of the reasons that we didn't get into a self-reinforcing ice age cycle is because water is peculiar in that it is less dense in its solid form. H2O is less dense, right? That's why your ice cubes float in your glass. Well, that's been very good for us because the oceans have not frozen solid, and that's allowed life to be sustained on the planet. It's also a disaster for the process of permafrost thawing, because even in the winter, the ice forms on the top of those new ponds and lakes, but they stay liquid underneath. And so the microbes continue to digest. Apparently, you can walk out on these frozen lakes and just see the bubbles coming up in the middle of the winter. And so, again, a very distressing phenomenon. Let me conclude by just sharing with you for a moment, which is some of the research I've been doing to keep up to speed on this. And in particular, I've been reading 2 books recently. One of them actually Matt prompted me to read when he was talking about releasing sulfur dioxide into the atmosphere, and that's Elizabeth Kolbert's Under a White Sky. The other is a book by a climate activist, a very interesting memoir written in the form of a letter to his unborn child, asking, in a sense, can he justify bringing a child into the world, given what he knows, right? So coming of age at the end of our world. The main title of the book is Warmth. The author is Daniel Sherrill. And reading these books have raised, I guess, 4 issues for me, which I want to talk about very quickly. The first is that we need a new ethics for a new age. And the new age is the Anthropocene, right? That is the age in which, Elizabeth Kolbert captures this with a kind of clever double entendre in her title, The Nature of the Future, right? One way to read that is, what's the future going to be like? The other is, what is nature going to be like in the future? And Kolbert looks an awful lot at various efforts to alter nature. And to give a very quick example, if we're going to preserve coral reefs, we're probably not going to be able to do it via standard ecological approaches. What's happening in the oceans is no longer under our control. And so laboratories in Hawaii and Australia are trying to do what they call extenuated or engineered adaptation. They're trying to uh, interbreed different species of coral. And as you probably know, coral is actually a living creature, even though it looks just like these big formations in the ocean. And to see if we can't breed species that are more robust in warm oceans, and then seed the dying coral reefs with the new species we've developed. So in the future, nature is going to be more engineered by us. We need ethics for this era, the Anthropocene, the era in which humanity increasingly alters, either intentionally or unintentionally, almost all major ecological processes on the planet. And in a sense, this new ethics needs to start with the foundation of all defensible ethics, which is the sense of the equal importance of all human lives. But as opposed to in the past, where generally speaking, yes, Western civilization has been built on discounting the worth or importance of people who are racially different, or women, or people who are distant from us. For the most part, we didn't have to take into account intergenerational justice, or the degree to which what we do here today in Northern California affects immediately or even relies on what's being done in sub-Saharan Africa or Southeast Asia, that we are interconnected in a way that is going to require imagination and care for the geographically and historically distant, those in the future, those who are far away from us, as well as care for other species. And so we need to be thinking through how we adjust our morality, how we adjust the way in which we think about the world for a world that is fundamentally altered by us. The second thing, and this is related, is that we really need to take seriously that we are facing a level of ecological collapse that will also produce civilizational collapse. And so when Daniel Sherrill is writing about the fact that he isn't sure he should bring a child into the world, he's not only worried that the world that she lives in will be less habitable in terms of its climate, but he's also worried that the world in which she lives will be one of increasing violence, war, and anarchy because of the effects of ecological collapse. And as awful as that is to contemplate, I think we need to do the exercise, to have the imagination to envision that in order to muster the will to do what we need to do now and to reconceive our ethical perspective to make sense of the new world that we are rapidly creating. Third, we need to develop carbon capture technology. We need to figure out ways to pull the carbon out of the atmosphere that we're putting there, maybe the other greenhouse gases as well. We in fact know how to do this, right? We do this on submarines, for instance, already, but it's very expensive, and it is very hard to do at a scale that is required to actually save the planet. Right now, it costs about $1,000 to take a ton of carbon out of the atmosphere. We need to take billions of tons out of the atmosphere. And so even if we can bring the cost down to $100 per ton, we're going to be spending hundreds of billions of dollars to capture and sequester carbon. And by the way, this is not just, pulling it out via chemical processes. That's one path. Another path is growing vast forests and either taking the material that is grown and building vast trenches and putting it into the ground, or perhaps even better, burning it and creating energy from it, and then capturing and sequestering the carbon from that energy, right? And having said all of that, it's not yet clear that this is possible at the scale that we need to do it. And so at the same time that we have to invest in and explore this, we need to be aware of so-called solution bias. There's got to be a solution lurking out there because our problem is so urgent. It does not follow because the problem is potentially catastrophic that there is necessarily a solution that we will develop in time to avert the problem. We're on a course to overshoot. We're on a course where we're going to put too much carbon in the atmosphere. We've got to work simultaneously on two levels to do everything in our power to arrest the amount of carbon and other greenhouse gases we're putting into the atmosphere, and then to figure out technologically if it is possible to pull some of it out. And then that gets me to the third issue, the one that Matt brought up a few lectures back. And this is the idea of geoengineering. For instance, putting sulfur dioxide into the atmosphere to reflect some of the sun's energy back out into space before it ever reaches the planet, right? And I want to be as clear as possible. There are lots of scientists working on this right now. Harvard has a major so-called solar geoengineering project underway right now. You talk to the scientists, as Elizabeth Colbert did, and many of them don't like the idea. They think it's way too risky. That one of them used the metaphor that it's akin to chemotherapy for the planet, right? And obviously, you don't want to drink poison chemicals or to have them injected into your body unless you have a cancer that is certainly going to kill you, unless you attack your body with chemicals, right? And in a sense, geoengineering is chemotherapy for the planet, right? The title, the main title of Colbert's book is Under a White Sky, because if we do this, if we put the sulfur dioxide into the atmosphere, as major volcanic eruptions have done in the past, the color of the sky will change. It'll be gray or white most of the time. By the way, the last time there was a major volcanic eruption of the scale to do this in a planetary way, there was freezing weather in Boston in August, right? And so one of the questions is, what does this do to photosynthesis? What does this do not only to human agriculture, where there were famines across the planet as a result of that volcanic eruption, but what does it do to photosynthesis, which is kind of the engine that drives biological life on the planet as a whole? Let me just add that when you ask those Harvard scientists, what's the most plausible way of doing this, they start talking about giant planes that will take billions of dollars to develop that fly into the stratosphere. It's almost like a cross between an airplane and a space shuttle to start depositing the chemicals that reflect the sunlight back out of the atmosphere. And they say, oh, and by the way, we'll probably have to fly these planes at least 400 times a day year round. And by the way, the result of that is going to be more carbon dioxide in the atmosphere. And so one of the deep hazards that comes with these models is that we end up completely reliant on ongoing and maybe even accelerating geoengineering to make the planet, to maintain the planet, I guess, in a habitable way. One of the metaphors that's used is, if you stop doing the geoengineering, it's like opening the oven door, and all of a sudden the heat just comes pouring in. And so you have camouflaged, disguised the extent to which the planet would be absorbing heat, but for the fact that you've put giant mirrors around it. And so, yes, unfortunately, we need to be thinking about doing geoengineering, but we certainly don't need to be complacent about it. Let me just show you one more thing here for a moment. And this goes back to 2012, the Intergovernmental Panel on Climate Change. And I hadn't really fully noticed this when I looked at this for the first time. You can see these are all the steps that the different countries of the world would need to do to get us to the point where we had only 1.5 degrees climate change. And if you look at this, the largest or the second largest element in each of these recipes is increase carbon dioxide capture. And basically, the Intergovernmental Panel ran tens of thousands of simulations and to try to figure out how to stop climate change. And the only simulations that worked, there were very few of them, only hundreds of them, all relied heavily on carbon capture. That is to say, a technology that we don't even have yet. And I'm seeing it's all right to go over 5 minutes. Is it all right to go over 15 minutes? Sorry, but that's what I've done. And it looks like I still got 32 of you here. I hope I'm not making you late for dinner. I'm actually late to pick somebody up. So I imagine you have questions or thoughts. Let's try to keep it to around 5 minutes, okay? Who wants to start us out? Matt, I see you there. What do you think? You were the one who, in a sense, launched me on this path.
Well, as for the geoengineering, I think you got to consider who we is. Any single nation could shade the entire Earth and solve the problem, sort of, with this kind of chemotherapy. And the only country that I know of that really would have the political will and capacity to do that is China. And so I've been carefully watching to see if there are any signs that China's about to do that. You know, you can go online and look at satellite photos of this and that. I haven't got a clean answer yet, but my betting is that at some point the Chinese will in fact ignore the ICC, ignore the United States and go ahead and do it.
And you and the Harvard scientists agree on this. And so what some of the Harvard scientists and the other scientists who are studying this say is, look, we don't like it. We don't want to do it. But use the analogy of chemotherapy, right? If you know the history here, and Malcolm Gladwell, sorry, has written about this, the doctors who developed chemotherapy killed a lot of people before they got it right. And we don't have that margin of error when we're talking about geoengineering, right? If we screw this up, we could accelerate the demise of the planet or bring it about overnight. And so what the scientists say is exactly the problem is that China or India or any country in the world can do this, and we want them to do it with the best science, the best information, the best models available. Doesn't mean we endorse it, but it's worthwhile doing the political calculus. If hundreds of millions of people are going to die in China in a 5-year period from out of control climate change, is the government of China going to allow that? Or are they going to take a risky course of action by trying geoengineering? They think that China will probably do it, and they want them to do it in as scientifically grounded a way as possible, so they're working on figuring out what that is.
Yeah, the other part of it that I think is interesting is I don't think airplanes are a way to go about it at all. Chinese have the means of putting an enormous amount of sulfur dioxide into the stratosphere anytime they get around to it with a nuclear charge. And they've got the necessary nukes to do that. They've also got the necessary material to pack on top of the charge so that it'll go up there. So that's my betting on how they'll do it if they decide to.
And I'm sure there's no adverse effects to letting off a bunch of nuclear weapons. I guess I can see why it is that the scientists who are interested in doing this in as sustainable and as minimally destructive a fashion as possible are thinking about airplanes instead of nuclear explosions.
Well, that's the Western people.
Yes.
You don't know what the Chinese are thinking. And by the way, there have been over 500 nukes set off in the atmosphere so far. And we're pretty much all still here. And you can get a worse dose of radiation from standing around in the park in New York than you get from some places where they've set these things off.
Or from what we're doing right now, staring at our screens. Yep. And on the other hand, the scale at which this would have to be done, I'm not sure that it is something that we should be too complacent about it not having planetary implications. Flossie, go ahead. You're muted. You're going to have to unmute yourself. Flossie, are you try talking now?
I'm trying here.
Yes, you're good now. Go ahead.
David, we can't kill the messenger, although I'd like to. But the thing we can do is put on our masks. I mean, we're fighting a pandemic in addition to everything else. The future does not look possible even, but I think I have to go back to our literature and say, at least we can be true to one another, and you have been true. You're telling us what you know, and we respect that. And then we have to go ahead with the little life that is left to us and be good to one another. I know that sounds like crap, but it's the only way for the while. So thank you and God bless you.
Thank you, Flossie. And I'm going to take it back to the framework I tried to establish at the end and suggest, because obviously you could walk away from this and feel quite desperate about human future, right? Suggest that there are 3 tiers of action here, right? The first is reducing the greenhouse gases now, right? Through individual action, but also through political action, because frankly, individually, we're never going to do enough. The second is funding the research that might allow us to pull the carbon out of the atmosphere, recognizing that the first stage is unlikely to succeed on its own. And let us hope that those 2 tiers of action together get us there, right? And that we don't have to do the geoengineering stuff because there are breakthroughs in carbon capture technology. Some of this is bioenergy with carbon capture, BECCS it's called, I think, grow the kind of tree that pulls the maximum carbon out of the atmosphere, burn it to get electricity and capture the carbon from it. We're not there yet, but at least we're able to envision doing this in an efficient way. And then if all else fails, geoengineering. And so when you think about it that way, it's sobering, it's awful. It's not impossible to envision a scenario in which we actually figure out ways to reverse the damage we've done. I think that's a good note to end on. I'm glad we were able to get together this week, and I'm glad you guys have the lights back on. And I will start a new lecture series with you guys next week, perhaps appropriately, about human reason and what we're learning about it. And it's the political implications of our predictable irrationality. All right, everybody, take care, be well, and I will see you in a little bit less than a week. Thanks. Good night.
Thank you, David.
Bye, guys.
Thank you, David.